Hi everyone, this is Mathematics with Simar. So I am Simardeep Kaur, Assistant Professor of Mathematics at Shahid Bhai Mani Singh Khalsa College, Longwal. So today we are going to discuss about asymptotes, right? A very important, you could say, a topic related to calculus, you can say. So we will discuss this today. So what we are going to discuss, so this is a really a little problem, right? So we are going to discuss introduction, we will have, then we will have definition of asymptotes, what are asymptotes, then we will discuss types of asymptotes, then after that methods to find the asymptotes, then after asymptotes of hyperbola, and then we will discuss some examples, right? So starting with introduction. So this is again, so sorry, we will continue like this because this problem is not solving here. So we will discuss, I'll read this for you. In geometry, an asymptote is a straight line that approaches a curve on the graph and tends to meet the curve at infinity. So asymptote is basically a straight line which is very close to curve, and it is a straight line very close to curve which never meets, or we can say that meets at infinity. An asymptote is a line that a graph of a function approaches but never touches or crosses as it extends towards infinity or a specific point, right? So asymptote never crosses the curve, it is going parallel with the curve, and we can say that it crosses at some point infinity or some specific point, right? Asymptote helps to describe the behavior of function, particularly their end behavior and behavior near undefined points. So why we are discussing asymptote? Because it is helping to find the nature of the curve or the function of the curve, its behavior, particularly their end behavior, right? Where it starts, where it ends, that the curve of the function, then behavior near undefined points, right? The behavior of curve where it is undefined, so asymptote helps to find that one behavior of the curve, right? In this article we have covered the asymptote definition, types, formula, example and others in detail. So we will discuss the definition, its types, its methods to find, right? We will discuss this all. Now definition of asymptote. So as we have already discussed, it was the definition, right? Previously what we have discussed. So a asymptote is a line being approached by a curve but never touching the curve. So it is a line, you can see in the figure, a curve is given and asymptote, a dotted line is that asymptote, right? So asymptote is straight line which never touches the curve, it goes parallel with very little gap, or you can say very little distance from the curve, right? Curve and its asymptote have a unique relationship where they travel parallel to one another yet never cross at any point other than infinity. So they are parallel, they're going parallel at infinity. We can say they never cross, but we can say they can cross at some point infinity, right? In addition, although they run closely together, they are still apart from each other. So we are seeing they are very close, but still there is a distance, very little distance between them. The distance between the asymptote of a function y is equal to fx and its graph is approximately 0 when either the value of x or y tends to infinity or minus infinity. So we can say the distance is very small, this is this much small that it is approximately 0, and we can say it is 0 when either x is infinity or y is infinity or approaches to minus infinity, right? So this is types of asymptote. There are three types of asymptotes basically: horizontal asymptote, vertical asymptote, and oblique asymptote. So one by one we will discuss all. So first is horizontal asymptotes. So horizontal asymptote is an asymptote which is parallel to x-axis, right? Parallel to curve also and parallel to x-axis as given in the diagram you can see. So horizontal asymptote, it is a horizontal line and hence its equation is of the form y is equal to k. Because it is parallel to x-axis, so its equation will be y is equal to some k. Example is also given: a function 1 by x whose curve is drawn, its asymptote is y is equal to 0, that is the x-axis, right? Y is equal to 0 is x-axis, so x-axis itself is the asymptote of the curve. Then second type we have vertical asymptote. So what is vertical asymptote? The asymptote which is parallel to the curve and is in vertical position, or we can say is parallel to y-axis, right? So it is parallel to y-axis, its equation is x is equal to k. An example is also given for function fx is equal to 1 by x minus 2, that is a curve is drawn and the vertical asymptote is x is equal to 2, which is parallel to x axis, which is parallel to y axis. Next we have third type of asymptote, that is oblique asymptote. So oblique asymptote is which is neither parallel to x-axis or nor parallel to y-axis. It is a straight line which is parallel to only the curve. So for this we have the equation, because asymptote is a straight line, so we have the equation y is equal to mx plus b, where m is the slope and c is some constant. Example is also given. You can see in the diagram also, curve is asymptote and the equation of asymptote mx plus. So for example, we have the function fx is equal to 2x square plus 3x plus 1 divided by x. The oblique asymptote is y is equal to mx, which is a, you can say, whose slope is 2 and constant is 0. Then we have methods to find asymptotes, right? So we are discussing asymptotes, types of asymptotes, then how we can find the asymptotes, right? So and this is a brief methods, so we will not discuss this, we will discuss this, that how to find horizontal asymptote, right? So for finding horizontal asymptote, the method to find horizontal asymptote changes based on the degrees of polynomial in the numerator and denominator function. So for finding horizontal asymptote, we have to check the function, or you can say the function is having a polynomials, right? So the degree of polynomial in the numerator and denominator of that function, we have to see that. If both the polynomial have the same degree, divide the coefficients of the leading term, and this is your asymptote. So if we have the polynomial of numerator and denominator with same degrees, so we can divide the coefficients of the higher degree term, the term with highest degree, the coefficient we can divide and we will get the asymptote. And if the degree of numerator is less than the denominator, then the asymptote is located at y is equal to 0, that is x-axis. So if the numerator's degree is less than denominator, so the simple asymptote is y is equal to 0. And if the degree of numerator is greater than denominator, so there will be no asymptote, or we can say that there is no horizontal asymptote. So example is also discussed. So we have the function 3x square plus 6x divided by x square plus x, and the degree of the numerator here is equal to the degree of denominator, so we will divide the coefficient. So leading coefficient of the numerator is 3 and the denominator is 1, right? So 3 divided by 1, that is 3, So we will have the horizontal asymptote as y is equal to 3, right? Then is method to find vertical asymptote. So to find a vertical asymptote of rational function, we simplify it first to the lowest term, set its denominator equal to 0, then we can solve this for x value of x, right? So basically what we have to do, we have to do first simplification. So there is numerator, denominator is some polynomials, so we have to simplify them. What is coming common or factorization is possible, we can do. So the lowest term we will find, then the denominator is put is equal to 0, and we will find the value of x. That value of x will be the vertical asymptote. Example is also given. There is a function, same function is there, 3x square plus 6x divided by x square plus x. So we will simplify this. We can take 3 from the numerator, 3 common, and then x also common. We will have x plus 2. Then from the denominator we can take x as common. So x plus 1, x plus 2, so x will be cancelled. We will have the terms, simplified terms, 3x plus 2 divided by x plus 1. So denominator we will put is equal to 0, that is x plus 1 is equal to 0. We will have x is equal to minus 1. This is the vertical asymptote, right? So there is a note that since x is cancelled while simplification, so we have cancelled out x in the upper simplification. uh, so x is equal to 0 the whole in the graph. So there will be, because there is no value for x is equal to 0, so there will be hole in the graph corresponding to x is equal to 0. We have drawn that graph. Here you can see there is the hole f for x is equal to 0. Then to find slant asymptote, or we can say oblique, slant and oblique are used, same terms are used to find oblique asymptotes. The slant asymptote of the rational function is obtained by dividing the numerator and denominator using long division. So in previous classes we have done long division method, so we will use that method to find the asymptote, that is oblique asymptote. The quotient of the division irrespective of the remainder preceded by y is equal to gives the equation of slant asymptote. So basically what we have to do, we have to divide the numerator and denominator using long division method, and the quotient we will get, so that quotient will be our asymptote, that is y is equal to, right? So example we can see, we have the function 3x cube minus 1 divided by x square plus 2x. So we will divide this by long division method, division is given, and we get the quotient, that is 3x minus 6. So by putting y is equal to 3x minus 6, we will get the oblique asymptote of this curve or function, right? So there are important notes on asymptotes, that is, if a function has a horizontal asymptote, then it cannot have a slant asymptote and vice versa. So if a function has horizontal asymptote, it is possible to find the horizontal asymptote, then we cannot find a slant asymptote, and if slant asymptote is found, then we cannot have the horizontal asymptote. Then in second, polynomial function, sine and cosine functions have no horizontal or vertical asymptote. So if there is a polynomial function or sine function or cosine function, then we will have no horizontal or no vertical. One of will be there, not both, right? Trigonometric function, cosecant, secant, tan and cot have vertical asymptote but not horizontal asymptote. So this we can find. Exponential functions have horizontal asymptote but no vertical asymptote. So any function given in exponential form, it will have horizontal asymptote only, not vertical. The slant asymptote is obtained by using long division of a polynomial. So this we have discussed previously, that slant asymptote can be found by division, long division method. So here are some references and links from where I have got all this information. You can check for more details, or for going deep into these concepts you can go through these links. This will provide a very good information to you. So this was all. So thank you so much for watching or hearing. So if you have any inquiry, any doubt, you can comment and ask. Thank you very much.